So we've got some normal distribution questions. We know that because we're getting a distribution and it's roughly normal with this this average and this standard deviation. So we want to find the upper quartile. So for A, we want the upper quartile or Q3. Right, now, if we draw our bell curve, we know that right in the middle will be the median or the mean. That's quarter 2. We want the upper quartile, which is quarter 3. And our lower quartile is down there. Now, if I want the upper quartile, I want 3/4 of that data. So that's 0.75. So that's my area. Now I've got my area and I want to find a value. So I'm going to do an inverse normal. So go to calculator, pick distribution, pick 3 for inverse normal. The area is 0.75. The standard deviation is 7, and our mean from the question is 25. Enter that, and it gives me a value of 29.72. So that means that this is in kilometers. Because remember, this is D, is the distance they travel to work. So that's A. B. Now we want the 30th percentile. Okay, so again, my bell curve, I know that here, my mu is 50. So I want the 30th percentile. So that's going to be below mu. So I want an area of 0.3. Now it's got the same mean and standard deviation, so just hit equals in your calculator, go back, change the area to 0.3. We've still got 7 as our standard deviation and 25 as our mean, and we get an answer of 21.3. Again, that's in kilometers. We're finding values of our discrete random variable. Okay, that's A, that's B. Now we want C. C is the value of Q2. Well, we know that Q2 is the same thing as the median. Okay, remember that for standard normal, or for normal, we know that the median is equal to the mean, which is right in the middle of our distribution. So that means that the area has to be 0.5. So again, still the same thing, just change the area to 0.5. Same standard deviation of 7, same mean of 25. And of course, it tells us that gives us a value of 25 kilometers because 25 is the mean that we're given here, which is basically halfway through our standard deviation. So that is A, B, C taken care of. Right. Now for question 7. A packing plant fills bags of cement. The weight X can be modelled by a normal distribution with the mean 60 and standard deviation 3. So that means that X is normally distributed with a mean of 60 and standard deviation of 3. Okay, now find the value of A such that P of X greater than A is 0.4. Well, what's important? This is greater, and to use a cumulative distribution, it has to be less. So we do 1 minus P of X being less than A is equal to 0.4. Okay, now if we know that's true, then that means that P of X less than A has to be equal to 1 minus 0.4, which is 0.6. Think about it on a bell curve. There's our median. Okay, so we want greater than 0.4. So remember, the mu is 0.5. There's our 0.4. We want greater than, which is this part. So we do 1 minus this, which is an area of 0.4. Okay. So now we need to find a value. So we know that area is 0.6. So then what we do is go to our distributions, inverse normal, 0.6 is our area, our mean is 60, and our standard deviation is 3. Hit that, we get an area of 60.8. Well, sorry, not an area, a value of 60.8. So our A value, A is equal to 60.8. And that's the value of X, which is weight. So that's in kilograms. Okay, that's A taken care of. Now B, find the interquartile range. Okay, well, interquartile range, we should know, is just Q3 minus Q1. So we find Q3 and Q1. Well, Q1 means an area of 0.25. Okay, same thing. So we just change the area to 0.25. It has the same standard deviation and mean. So that gives me a value of 57.976. I do Q3, we know that that is 75%, so the area is 0.75. Again, all we have to do in a calculator is change the area, and I get a value of 62.023. And I'm going to do Q3 minus Q1, and I get a range of 4.047. And that is my interquartile range.